Right, we've got one more factoring technique that we'll be learning this unit, and that is called advanced factoring. At the end of this lesson, you'll be able to factor a polynomial using the GCF and then other factoring techniques. All right, the problem will say factor completely, and when it does, I like to refer to this section as Factorception. And if you recall, when we were watching Inception, they would keep going in a dream, and as soon as they got into a dream, they'd open into a new dream and then to a new dream. So they're going to a dream within a dream, and that's basically what's going to be happening with factorception or factoring completely. We'll factor, and then we get to factor within a factoring problem. So once we factor using the GCF, we'll get to factor again. What we're going to be doing is making sure the polynomial is written as a product of linear polynomials, so degree 1, with integer coefficients. And usually, actually I'm going to put always, start this process by looking for a GCF. So we will always do the GCF first, and then what that should do is open up a new factoring problem for us to do. So factoring within factoring. Right, as an example, let's say I have 3x cubed minus 75x. Okay, the first thing that we definitely want to do is look for a GCF. I notice that 3 will go and do both of the numbers, and if I'm going to pick x cubed or x, it's going to be x because that's the smaller power, and then we'll divide both terms by 3x. So when I do that, I'm going to get 1x squared minus 75 divided by 3 would be 25, and then the x's cancel out. Okay, so we've factored using the GCF. Now notice what happened. We have just opened up a new factoring problem because x squared minus 25, you can square root the 25. So the way that this is going to factor is x plus 5, x minus 5, and then that 3x just tags along into our answer. So we basically have a factoring problem within a factoring problem. All right, let's try the next one. Let's put 3x cubed minus 21x squared minus 54x. All right, the directions again would be saying factor completely, so you'd know that we want to factor using the GCF and then keep going. If I looked at what number goes into all three of those numbers, it would be 3. And if I have to pick between x cubed, x squared, and x, I'm going to pick x because that's the smallest power. And then we'll divide each of those three terms by the 3x. So when I do that, 3 divided by 3 is 1. X cubed divided by x, we're going to subtract our exponents and get x squared, and then minus 21 divided by 3 is 7, x squared over x is x, and then minus 54 divided by 3 is 18, and then the x's, since they're the same, go away. All right, so now notice again, we've opened up a whole new factoring problem, and if you recall from this problem, if it's a quadratic trinomial, we'll factor it with x and x. We'll take our 1 times our negative 18, and I'll be looking for what times what gives me negative 18, negative 6 times 3, negative 3 times 6, negative 9 times 2, negative 2 times 9. Which one of those will add to give me negative 7? It will be this one because negative 9 plus 2 is negative 7. So minus 9 plus 2, and this 3x tags along for the ride. So that would be factored completely. All right, I'm hoping that at this point in time you'd like to pause the video and come back and see how you do on it. Let's put a 12x squared here. First thing we're going to do again is look for that GCF. 2 will go into all three numbers, and then x cubed, x squared, and x. I'm going to put the x because it's the smallest. So we'll divide all three terms by the 2x, and when I do that, I will get 2 divided by 2 is 1, x cubed over x is x squared, minus 12 divided by 2 is 6x plus 9. All right, and then from here, what that has done is opened up a whole new factoring problem for us. Since it's a quadratic trinomial again, we'll put our two x's, x and x. We'll take 1 times 9, that will give me 9. What times what would give me 9? 9 times 1, 3 times 3, negative 9 times 1, negative 3 times negative 3. I'm looking for negative 6, so negative 3 plus negative 3 would give me negative 6. That 2x comes along for the ride, and then if I wanted to be real fancy on this one, we could rewrite this as 2x times x minus 3 quantity squared. So that's what it would look like factored completely. All right, one more. Hopefully you'll be able to try this one as well on your own too. Pause the video and then come back and see how you do. Right, first of all, we will be looking for that GCF. So the first thing I'm going to do is look at what number would go into both of those. It would be 2. And then if I'm going to pick x to the fourth or x squared, it's going to be x squared because that one's the smaller of the two. So then I'll divide each term by 2x squared. 2 divided by 2 is 1. X to the fourth divided by x squared is x squared, minus 18 divided by 2 is 9, and then the x squareds cancel out. Right? Once again, I've opened up a new factoring problem because we can square root the 9. So this is going to be x plus 3 times x minus 3. And then we'll just let the 2x squared tag along for the ride. So now hopefully you can factor completely or Factorception.